Welcome on Vandana Classes YouTube channel Darbhanga. Today I am going to discuss some important topics regarding polynomials and hope you have to enjoy this session. In this video I am just trying to discuss division algorithm on polynomials, and after that I will discuss two different theorem, factor and remainder theorem. So please keep watching Vandana Classes YouTube channel Darbhanga, and also you have not requested that to subscribe this channel because I know that your love with me. My dear student, in the last video I taught you that definition of the polynomials, and also I described the strength of the polynomial. Do you know that a polynomial is none by their degrees, because strength has been found out of any polynomial is their degree. Degree, you know very well that degree is the highest power of the polynomial. Let's see some example. 2x plus 4, 3x squared minus 9, 4x cubed plus 2x plus 4. Now in these three polynomials, if it is said that which has higher degree, you know very well that this one has degree 1, because highest power is 1, and degree has been find out the power on the variable, and variable is x. In all the cases I have just taken the singular one in all three polynomials, and it has degree 1. In second case degree is 2, because you know that highest power is 2 in this case. In the third case you know that power is 1, power is 3, but highest power is 3, my dear. So in all three cases you can just say that which one has the highest degree. Actually third polynomial has the highest degree. While doing the operation on the algebraic expression on polynomials, it is quite essential to pay attention on the degree of the polynomial, because all the calculation are ranging from the degree to degree. Suppose that you are dividing px by qx, because you know that there is also a difference. Actually I was just discussing that what is the meaning of p. P is a p. When you write down p, then p refers to constant one, and when you write ps, then px refers to a polynomial. That is the basic difference while writing p and px. Similarly, when you write r refers to any constant polynomial, any number, whatever. When you write rx, then rx refers to a polynomial. And you know that when you compare two different polynomial, px and rx, px is one polynomial, rx is another polynomial, and if you say that which is the senior polynomial, greater polynomial, a higher polynomial, because polynomial is also compared. Not only constant has been compared, 4 is greater than 2, it has been just compared. Similarly, you can also compare two given polynomials. Px is one polynomial, Rx is another polynomial, and you can just discuss which one is greater and smaller. That is on the basis of degree. Suppose that Px is third degree and Rx has 2 degree. Then which one is greater? Px is greater than Rx, because Px has higher degree as compared to Rx. Here I was just discussing that A is a positive number, B is another positive number. When A is divided by B, their quotient is Q and remainder is R. In this case, you can just see that if you compare B and R, then what you have just noticed that R must be less than B R must be less than B, because remainder cannot be equal to the divisor or cannot be greater than the divisor. Two conditions cannot be possible in the case of divisor. For example, you can just see that if 17 is divided by 4, then you know that 4 4 is 16 and 1. Here remainder is 1. When divided by 17 is divided by 4, remainder is 1. 1 is less than 4. Similarly, my dear, when any polynomial px is divided by gx, that is another polynomial, and quotient is qx and remainder is rx. Here you have to just pay attention that remainder means this polynomial must be less than, as compared, their degree must be less than the degree of gx. It may equal to 0, means degree. Either its degree is equal to 0 or its degree is less than the degree of gx. For example, if the degree of gx is 2, then the degree of rx must be smaller than degree of 2, that is either 0, 1, 0 and 1. Two possibilities are. If the degree of gx is 3, then rx has 3 possibilities: 0, 1 and 2. Similarly, if the degree of gx is 10, then rx has 10 possibilities from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. But degree cannot be equal or greater. If the degree of gx is 10, then degree of rx cannot be 10 or more than 10, means 11, 12 and so on. So while you have just doing the division algorithm previously, you have to just focus on the degree of divisor and degree of remainder. And you know that this is dividend, this is divisor, this is quotient, and this one is remainder. So its degree must be smaller than the degree of gx. I am going to discuss about the division algorithm in polynomials. Ps and gx are two given polynomials. Ps and gx are two given polynomials, and it has given that degree of px is greater or equal to degree of gx, because you know very well that either equal divisor, degree of the divisor either equal to degree of dividend or degree of divisor may less than, because greater cannot be. For example, x3 plus 4 cannot be given to divide of x plus 3, because this division process cannot be completed, because degree of divisor is here 3 and degree of dividend is actually 1. So degree of divisor cannot be less. So it always be greater, or it may be possible. Suppose that x minus 4 or x plus 3. This may be possible because degree of divisor is 1 and degree of dividend is also 1. Degree may equal, or it is possible that x plus 5 and x squared plus 9. Now this division process may proceed, because here degree of the divisor is less as compared to degree of dividend. So degree of divisor always be less or equal to degree of dividend. Here degree of px, because we are going to divide px by gx. When px be divided by gx, then you can just notice when px is divided by GS, then PX is here dividend. And dividend, and what is GX? GX is actually divisor. So degree of GX either equal to degree of PX or degree of GX is less as compared to degree of PX. Now you can just see that. Or divided to two condition, you have to just write down degree of px is greater or equal to degree of gs, and on dividing px by gs, let quotient be qx and remainder is rx. Then according to this division algorithm, px is equal to gx into qx plus rx. And you know, my dear, where Rx is either equal to 0, 0 in the case of completely divisible, and or degree of Rx is less or equal to degree of GX. So finally you can just say that PX is dividend and GX is divisor, QX is quotient and RX is remainder. This formula can be written also as dividend is equal to divisor into quotient plus remainder. Degree of GX is either equal to degree of PX, or GX, degree of GX is less as compared to PX. The relation between GX and RX is either RX is equal to 0 or degree of RX is less as compared to degree of GX. My dear students, now I am going to discuss about the verification of the division algorithm on polynomials. Here I have just taken px is equal to x cube plus x square plus 2x plus 3, and it is divided by x plus 2, means px is here x cube plus x square plus 2x plus 3, and gx I have just taken x plus 2. And when it is divided, because division process I can't mention here because this video is already too long, and in other video I will discuss how to divide polynomial by another polynomials. When you divide, then quotient you have just find out x square minus x plus 4, and remainder is minus 5. So I have just considered qx and rx. Now according to division algorithm, you know that quotient into divisor plus remainder is equal to dividend. And this is why I have just written RHS side of this division algorithm, GX into QX plus RH. You can just discuss the degree that I have just mentioned. Here the degree of PX is 3 and degree of GX is 1. So you have just to see that it is the senior or higher polynomials and this is lower polynomial. Similarly, you can just see that here Rx is minus 5, and what is degree? Degree is 0, and what is degree of Gx is 1, because x the power is 1. So 1 is higher as compared to 0, so it certifies all the conditions that you have just read now. And when you multiply, and you already know how to multiply in the previous standard. On multiplying, I just get x cube plus x square plus 2x plus 3, and it is the px which has been given in the questions. So it is verified. By this way, you can divide and you can verify this formula. If it is not matched because it is applicable to all, and this is why you have to just pay attention. If you have just verified and Px do not equal to Ex into Qx plus Rx, it means your calculation is anywhere there is a mistake. So you have to recheck your calculations, and this must be equal in all aspects. My dear, the question has been given from RS1 I have just taken. Px is equal to 2x4 minus 6x cube plus 2x square minus x plus 2, and the value of gx has been given x plus 2. And first you need to divide. The degree of Px here is 4 and degree of dx is 1. So division is proceed easily. 2x to the power 4 minus 6x cube plus 2x square minus x plus 2. Let's do divide, and you know that it can easily be divided because you know and learn in the 2x cube is taken quotient, 2x cube is multiplied by x, then 2x to the power 4 plus 2 is multiplied by 2x cube, then 4x cube. On subtraction, this term is cancelled, and this one is 10x cube plus 2x squared. 1 is taken from the dividend side. Then you have to take minus 10x squared. So minus 10x cube and plus minus 2 into 10x squared means 20x squared. Minus change into plus, minus change into plus. Both has been cancelled, and 20x squared plus 2x squared. 22x squared minus x. And now you have to take plus 22x. Then 22x squared plus 44x. Now minus plus change into minus, this term has been cancelled. So 45x, and last one is plus 2, and this is why you have to take minus 45. Minus 45x minus 90, and you can just see that plus this term is cancelled, and what is the result? What is the remainder? 92. The division process has been completed, and now you can just check that by division algorithm, we know Px is equal to Qx into, or you may write Gx into Qx plus Rx, and now RHS side, at first I have just taken RHS, that is Gx into Qx plus Rx, and what is the value of Gx has been given x plus 2. The value of Qx has been given 2x cube minus 10x squared plus 22x minus 45, and plus what is the remainder? 92. You may write here you may write Qx is equal to 2x cube minus 10x squared plus 22x minus 45, and Rx is equal to 92. And when you multiply, for the verification you need to multiply, and while you doing the multiplication, 2x to the power 4 minus 10x, I just multiply x to whole the term, 10x cube plus 22x squared minus 45x plus 4x cube minus 20x square plus 44x minus 90 plus 92. And on simplification, you can write 2x to the power 4 and 4x cube minus 10x cube. You may write minus 6x cube. Then you have to just see that 22x square minus 20x square plus 2x square plus 44x minus 45x, then minus x, and last one 92 minus 90 plus 2. And you can just see that this is matched to the px that is given in the question. It is equal to px, so it is very fine. My dear, hope you have to understand the division algorithm in this video on polynomials. In next video, I will discuss a remainder theorem and factor theorems, and hope you have to enjoy whole the session. Keep watching this video channel. Thank you very much.